Welcome, grade 10 learners. So, how are you today? I hope that you are all fine and safe from the COVID-19 virus. Before we will start with our lesson this morning, let's try to have an activity named aquarium fishing as a review. Okay, let's read the situation. Steven wants to buy a fish, so he went to a fish store. He saw this aquarium and wanted to buy a fish inside it. How many fish of each color are there? What is the total number of fish swimming inside the aquarium? And what is the probability that Steven will reach in and scoop out a blue fish or red fish on his first scoop? Okay? In order to find the answers of the given questions, let us try to identify first the number of fish in the aquarium by color. A red fish inside the aquarium, and there are 6 blue fish, 14 are orange, 5 are green, and the total number of fish inside the aquarium is 30. Okay, so in order to find the probability of blue fish, we have to use this formula. Probability of blue equals 6 over 30. Why 6? Because there are 6 blue fish inside the aquarium and there are 30 total number of fish in the aquarium. That is why it's 6 over 30. And then we will simplify. This will become 1/5. Okay, the next is we're going to find the probability of scooping a red fish. So probability of red equals 5 over 30. And why 5? Because there are 5 red fish inside the aquarium. And over 30 is the number of, or the total number of fish inside the aquarium. Very good. And we will simplify 5 over 30. This will become 1/6. Okay. So the third question is, what is the probability that Steven will reach in and scoop out a blue fish or a red fish on his first scoop? So using the formula in probability, probability of blue or red equals the probability of blue plus the probability of red. So we know that probability of blue is 1/5. So we will substitute here 1/5 plus the probability of scooping red fish is 1/6. So we will write here 1/6. 1/5 plus 1/6 equals 11 over 30. So that is the probability that Steven will reach in and scoop out a blue fish or a red fish on his first scoop. Okay. So I have here a question. What is the importance in studying probability in decision making? And can you give statements in real life situations that involve probability? Okay. So probability is important in making decisions because it will give us an idea whether are we going to take the action or not. It will give us an idea on the advantages and disadvantages on the action you are going to take into consideration. Okay, examples of probability statement. There is 20% chance that it will rain tomorrow. Another example. Since it is sunny and hot, it is very likely that I will go to the beach today. Okay? Can you give more examples? Very good. Our lesson this morning is all about the probability of union of two events. Let us read first our objectives. Number 1, Find the probability of A union B. Number 2, perform the process in finding the probability of A union B. Number 3, apply rules in finding probability of union of two events in solving real-life situation. So these are the objectives that we are going to do this morning. Next, from the previous activity that you have done, how did you arrive your answer? Okay, by using the formula in solving the probability of an event, which is probability of E. E here stands for the event, equals the number of ways the event can occur all over the number of possible outcomes. Just like our example a while ago, probability of blue. Blue here is the event, scooping of blue fish. And 6 here is the number of ways the event can occur. And the denominator here is the number of possible outcomes, or the total number of fish inside the aquarium, which is 30. And simplify 1/5. Okay. Another example here. Probability of red equals 5 over 30. 5 here is the number of ways the event can occur. And 30 here is the number of possible outcomes. Okay, that's good. So, the question here, what is the probability that Steven will reach in and scoop out a blue fish or red fish on his first scoop? So, using this formula, probability of blue or red equals the probability of blue plus probability of red. Then substitute the probability of blue 1/5. Probability of blue event, a red event is 1/6. Add 1/5 plus 1/6 equals 11 over 30, or a 37% chance of scooping a red fish or a blue fish inside the aquarium. Is it a great possibility? Okay, yes, that's correct. Let's proceed. So I have here a situation. Suppose we're playing a card game, and we will win if the next card drawn is either a heart or a king. What will be the probability of the next card of being a heart or a king? So are you familiar with this card game? Okay, that's good. What is the first thing that we are going to do? Okay, that's right. We are going to note how many cards are there in the standard deck of cards. How many cards? That's correct. There are 52 cards in the standard deck of cards. Next, what are the cards to be drawn for us to win? What do you think? That's right. It's either a king or a heart card. Very good. Next, what is the probability of getting a king or getting a heart? Using the formula, probability of king equals 4 over 52. Why 4 here? Okay, very good. Because there are 4 king cards in a standard deck of cards. And why 52 here? That's right. It's the total number of cards in a standard deck of cards. Now, what is the probability of getting a heart card? Okay, so probability of heart here, this is the event, equals 13 over 52. Why 13? That's right. There are 13 heart cards in a standard deck of cards. And 52 here is the total possible outcomes or the total number of cards in a standard deck of cards. Very good. Next question. There are 4 king cards in a deck of cards, and there are 13 heart cards. But there is one king card that is also a heart. The king of heart cards is both a king and a heart card. So, in order to find the probability of union of these two events, we will answer the question, what is the probability that the card to be drawn is a king or a heart? Okay, so using the formula, probability of king or heart equals the probability of king plus the probability of heart minus the probability of king and a heart cards. Okay. So, we know that there are 4 king cards in a standard deck of cards. So, using the formula by substitution, we have probability of king or heart equals 4 over 52. This is the probability of the king card. And plus 13 over 52, which is the probability of heart card, minus here 1 over 52. Why 1 over 52? Okay, that's correct. Because there is one king card that is also a heart king card. That is what we call the king of hearts. So that is why we need to subtract 1 over 52 here, because that king card has already been counted in the first event. So we have to subtract 1 over 52. So 4 over 52 plus 13 over 52 minus 1 over 52, which is the king of heart cards. So this is 16 over 52. And reduce that to lowest term, this will become 4 over 13. Okay, in order to understand better on that activity, we are going to use the Venn diagram to illustrate further. So we know that this first event here is the king card, and the second circle is the heart event, and this is the overlapping region, which is the intersection of both events. So we know that there is one king of hearts card. So we are going to write 1 here inside the intersection, because this one card is both a king and a heart. So we know that there are 4 king cards in the standard deck of cards. So we have to write here 3. And then we know that there are 13 heart cards in a standard deck of cards. 12. We need to put here 12. So 12 plus 1 is 13, and 3 plus 1 equals 4. So this is the illustration of using the Venn diagram based on the situation that we have mentioned a while ago. So what is there? 36 here. Okay, so since there are 52 all-in-all cards, and we have 4 kings and 13 hearts, so we know that there are 52 cards. So the rest of the cards do not belong to king or a heart. That is why it is written outside the 2 circles. Okay, let's proceed. Okay, let's have another activity. Are you familiar with the GCCAA? Correct. So, Hingog City Division conducted their GCCA Meet 2020. The grade 10 students of Mimbunga National High School qualified and participate the said event. The Venn diagram on the right shows the probability of grade 10 students joining either soccer or basketball. Okay, so this is the Venn diagram. We are going to use this Venn diagram to answer the given questions on the right. So this is number 1, question number 1. Use the Venn diagram to find the probabilities. Okay, so this is the event of basketball. So we are going to write 0.4 plus 0.3. Just add those figures. This will become 0.5, 0.7. Okay. What is the probability of soccer? So this is the event of soccer. So it's 0.2 plus 0.3 equals 0.5. Number 3, what is the probability of the intersection of basketball and soccer? So this is the symbol of the intersection. So by just looking at the Venn diagram, the overlapping region here, okay, it's 0.3. So this is the intersection of basketball and soccer event. So this is why 0.3. Okay. For number 4 question, what is the probability of basketball union soccer? Previous discussion earlier that in finding the probability of union of two events, so probability of basketball plus the probability of soccer minus the probability of the intersection of both events, which is basketball and soccer. So by substitution, the probability of basketball is 0.7 plus probability of soccer is 0.5 minus the intersection of both events, 0.3. So 0.7 plus 0.5 minus 0.3 equals 0.9. Okay, so let's have another activity. So look at the spinner. Okay, we have here the spinner. There is letter A here inside the orange region, 2 A's and B, and we have here another letters. So what is the probability of spinning orange or spinning B? Okay. So let us try to find first the probability of the first event, which is spinning orange. So probability of orange equals 3. Why 3 here? Because there are 3 slices or region of an orange here. So we have 3 over 6. And why 6 on the denominator? Because there are 6 slices or 6 regions of the spinner. So that is why it's over 6. 3 over 6 equals 1/2. So our probability of spinning an orange is 1/2 or 50%. Next is the probability of spinning B. Okay, so we have here probability of B equals 2. Why 2 here? Because there are 2 B's in the spinner and over 6 the total number of regions in the spinner. So 2 over 6 equals 1/3. Okay, so what is the probability of spinning an orange or B? Okay, so we know that in finding the probability of union of two events, we are going to add the two events minus the intersection of two events. So probability of spinning orange or B equals 1/2. 1/2 here is the probability of an orange plus 1/3, which is the probability of spinning B, minus 1/6. Why 1 here? Okay, that's right. We have to subtract 1 because there is a B under the orange region that is already counted on the first event. So there are 2 B's here, 2B. But 1B belongs in the orange region. And we know that we already found the probability of orange, which is 1/2. That is why we need to subtract 1B for the intersection of these 2 events. So 1/6. Okay? So 1/2 plus 1/3 minus 1/6 equals 2/3. Or we have a chance of 67% in spinning orange or B. So is it a greater chance or not? Yes, it's a greater chance of spinning orange or B. Okay, is it clear? Okay, very good. So let's proceed. Suppose that in a class of 30 students, 8 students are in band, 15 students play a sport, and 5 students are both in band and play a sport. Create a Venn diagram that models this situation and find the probability that the students join in band or in sports. So in order to illustrate this situation, we have to use the Venn diagram. So this first event is for the band, second is for the sport. And we know that there are 5 students joining in band and in sport. That is why we have to write 5 here, because this is the intersection of these 2 events. And we know that there are 8 students join in band. So we already have 5 here. So we need to write 3. And there are 15 students joined in sports. So we have already 5 here. And we need to write 10, total of 15. Okay, so in this Venn diagram, there are 8 students joining in band and there are 15 students joining in sports. And the rest of the students did not join either in band and in sports. That is why they belong outside these 2 events. Okay. So question. If a student is randomly chosen, what is the probability that the student joined in band or in sports? Okay, so using the formula in finding the first event, which is the band, so 8/30, because there are 8 students out of 30 joined in band, or 4/15. And for the sport event, we have 15 students joining in sports out of 30 students. So this is 1/2. So what is now the probability of randomly choosing students join in band or sports? So using this formula, probability of band or sports equals 4/15, which is the probability of the band, plus 1/2, the probability of sports, minus the 5/30, because there are 5 students who join in band and in sports. So we have to subtract 5/30 because this has been already counted on the event of band and sport. 4/15 plus 1/2 minus 5/30 equals 3/5, or a chance of 60% that we can choose a student either from band or sports. Okay. To generalize that idea, the probability of the union of 2 events E and F, written E union F, equals the sum of the probability of E and the probability of F minus the probability of E and F occurring together, which is called the intersection of E and F, and is written as the intersection of E and F. But this is probability of E union F equals the probability of E plus probability of F minus the probability of E intersect F. Okay. So for your evaluation, I will group you into 5 and you're going to perform different tasks. After that, you're going to share your work. In each group, you'll select a leader, secretary, and a reporter. So these are your activity. It is named as Chips Ahoy. So read the situation. Okay, for the group, what's in the box? For group, don't break my heart. So read the situation and answer the question. Or it is named as What's Your Ink? This is Put Me in a Song. You're going to write a song about taking chances. You can use any melody of a song but just change its lyrics. Taking chances, because when we say probability, it is possibility or chance. Okay, very good. An assignment. So out of 5,000 households surveyed, 2,107 had a dog, 807 had a cat, and 303 had both dog and a cat. What is the probability that a randomly selected household has a dog or a cat? Use a Venn diagram to illustrate your answer. Explain the process in deriving your answer. So I hope that you learned something from today's lesson. Thank you. Happy learning.